Now we go into lesson 4.3, odds and expected values. Odds of an event occurring have become more popular because internet gambling has gotten more popular. If you watch Sports Center or any sports show, you can find the betting odds for making a wager on a sports game. They are a bit different than the ones, the way that we're going to talk about it today. But my main point here is that odds and probability, they get interchanged, but they're different things. Odds look the same or feel the same, or really, I don't even know if they feel the same or look the same. I think we all just kind of chunk all that into math. Odds and probability are different things. So how are they different, right? So both of them describe the likelihood of an event occurring. Probability tells you here are, so if I said, go back to probability, and like we talked about before, probability, remember that capital P means probability of event. E, let's say, we did this one earlier, say it's 0.3, 3 times, right? So doesn't that mean there's 30% chance it's going to happen, 70% chance it doesn't? All right, probability tells me the likelihood, or describes the likelihood of an event occurring. Odds, on the other hand, do not. Odds directly compare all of the favorable and unfavorable outcomes in an event. So the odds in favor of event E occurring are A over B, or A to B. Okay? I do not love writing these as fractions. If you're going to deal with odds, I think writing it as the ratio A colon B, or even writing A to B. I like those two as the best. And you'll see why in just a bit. Odds against event E occurring are B to A. So remember, I have A favorable outcome, so I'm flipping a coin. All right, I'm flipping a two-sided coin, and I got, or let's make it a dice. Let's make it a die. Rolling a die. What is the odds, or what are the odds against rolling a 3 or a 5? All right, so what are all the possible outcomes? 1, 2, 3, 4, 5, 6. Okay, so of these, which ones are favorable? Which ones give me what I want? Well, if I roll a 3 or if I roll a 5. Which ones are unfavorable, meaning I do not satisfy what I'm looking for? 1, 2, 4, and 6. Okay, so if A, the number A is my favorable outcomes, A is 2, and B is my unfavorable outcomes, it's 4. So that means odds against rolling 3 or 5 would be, odds against means I put the unfavorables first, or on top. So how many unfavorables are there? There's 4 ways to fail and 2 ways to succeed. Okay? If I did odds in favor, the number that goes first is the number of successes or favorable outcomes. The number that goes second are the unfavorables. Now, I know you're thinking, hey, wait a second, this is exactly like what we did in probability. It's not. And the reason I know that is because probability of rolling 3 or 5 is what? Well, it's a fraction. There are 6 outcomes and 2 of those 6 are favorable or satisfy what I'm looking for. And then that would reduce to 1/3, but that's beside the point. Probability compares the number of successes to the total number of possible outcomes. So inside that 6, there are the 2 successes and the 4 failures, or 2 of the favorables and 4 of the unfavorables. Odds directly compares these numbers. Now, this is the reason I don't like writing odds as fractions, because the odds against would be 4/2. The odds in favor would be 2/4. Those look like probabilities, right? So I like to distinguish odds and probabilities because of the way I write them. So I'd rather write it 4/2 or 2/4. You'll be asked to do different things. If you're asked to write as a fraction, go ahead. But that's just how I try to separate the two, make sure that I know, hey, these are odds because I'm using the ratio with the colon, and this is a probability because I have a fraction. All right. So another example here, just after the 2019 Super Bowl, Las Vegas had listed the odds against the Patriots winning it again in 2020 as 8-1. All right, write these odds against the Patriots repeating as a fraction and as a ratio. All right, so these are odds against, and that's what you're usually going to run into. So if I have odds against, are 8-1. This is against. So the first number that I see is the number of unfavorables. And the second is favorables, right? If I want to write that as a fraction, yes, it is 8/1. Okay. Now, here's the issue. Based on that, what is the probability that New England repeats? All right. How many successes did we have in there? Well, we had 8 unfavorables and 1 favorable. So 1 on top, and that is 9 elements total. Okay. And then if I wanted to get technical and say, wait, these are on the different sides, what's the probability that New England does not repeat? Okay. 9 possible outcomes, 8 of them are failures. Okay. And that's what odds against, 8-1, they do not repeat, 8/9. So I hope we're getting a feel for that and how we can see that odds and probability, while they do get confused or just kind of jumbled together as, oh, that's that stat part of the math class, they are not the same thing. All right, so here's just a little, did you get it? What are the odds in favor of rolling a prime number sum with a roll of 2 dice? What are the odds against? Use the table below to that shows all the possible rolls. Okay, so this table just has, I'm rolling 2 dice, and the first one is 1 die. The second number in the parentheses is a second die. They look kind of like coordinates. But I'm looking for a prime number sum. Prime numbers are all the numbers that cannot be, that are only divisible by 1 in themselves. So I'm going to give you a quick primer. That's stupid, don't say that. I'm going to give you just a quick list of the prime numbers that we're going to encounter. So we have 2, 3, 4 is divisible by 2, 5, 6 is divisible by 2 and 3, so it doesn't go in here. 7 has no, 8 is divisible by 2, 9 is divisible by 3, 10 is divisible by 5, 11, 12 is divisible by 6, 13, 14 is divisible by 2, 15 is divisible by 5, and wait a second, you can't even get 13 on the die. So these are all the prime numbers that we're going to encounter. So if I roll 2 dice and I end up with a sum of 2, 3, 5, 7, or 11, I have hit a prime. All right, so let's find them all. Well, 1 and 1 is going to make 2, yes. and 2 and 1's going to make 3. 2 and 1's going to make 3. Make a 5. How do I make 5? 4 and 1. Note that. Yeah, 4 and 1. 3 and 2. 2 and 3. 1 and 4. Now we see the pattern, right? As I go down this table, as I go down the table we've created here, if I run diagonally, all of those numbers or all those outcomes that land on that same diagonal have the same sum, right? So we just saw it here. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. So 7s, I can get 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. So the next diagonal would be 8s, 9s, 10s, and then here's 11. 5 and 6 and 6 and 5. So A are favorables, so favorable outcomes. How many of those are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 15 of those. And then unfavorable, or you've heard me call it successes and failures. That is represented by B, and that is 17. So, rather than me trying to type any more, what are the odds in favor of rolling a prime number? They are what? Odds in favor means favorables go first, so it's 15 to 17. And then odds against rolling a prime number. And again, I'm not writing rolling 2 dice and getting the sum. I think we can assume that we know that. Odds against would be 17 to 15. What about probability? Probability. If I could spell it. Probability rolling a prime number. Okay. What is that? Well, there are 15 ways to do it. And instead of comparing that directly to the number of ways to fail, I'm comparing it to the total number of possible outcomes. And this total number of outcomes, I got 6 on the horizontal, 6 on the vertical, so there are 36 possible outcomes. So that becomes my denominator. And that helps us, again, distinguish between, hey, it's really obvious, this is a probability. I didn't mean to do that. It's really obvious that 15 over 36 is a probability, and it's really obvious that 15 to 17 is a set of odds.